This is Lesson 6.1, Solving Equations, Part 1. Before we begin with the lesson, go ahead and complete the 2 Do Now questions review from the previous units. Push play when you're ready to go over the answers. Alright, in question number 1, you are asked to evaluate 2x plus 1 if x is equal to 3. If you recall, this simply means that you plug in the variable wherever you see x, you replace it with 3, and then you can simplify using the order of operations. So we do 2 times 3 equals 6 plus 1. Because we turned it into a numeric expression, you use the order of operations, and you get 7 as a final answer. So when you evaluate, your final answer should be a numeric single answer. In problem number 2, you're asked to simplify. Remember, when you simplify, this means 2 things. Remove parentheses if there are any with the distributive property, and then combine like terms. So the first step, distribute. You multiply the 3 to the 2 inner terms. 3 times 2x is positive 6x. Because it's the first term, we do not need to have the sign in front of it unless it would have been negative. And 3 times 1 is positive 3. Here you do need to have the sign in front of that 3 because it is not the first term in the answer. You bring down the negative 7 because it's outside of those parentheses. It's not what you're going to distribute in. And then we're ready for part 2, or step 2 of simplifying. That's combining like terms. So if you identify your variable terms, I'm going to go ahead and put a circle around it, and then identify your constants, those terms that do not have any variables. I'm going to put squares around them. You can clearly see what you need to combine. There's only one variable term, so I can just copy it down, the 6x. But there are 2 constants. I need to combine them. And remember, when you combine, that's when you use the rules of SOB. These are opposite signs, so we have to subtract. And because our negative number is bigger, when you combine it, you should get a negative 4. So our final answer when you simplify is usually more than one term and can still contain a variable in it. In today's lesson, we're going to be solving equations, not expressions, but equations. Remember, the big difference between an expression and an equation is that an equation has an equal sign in it. When you see the word solve, it simply means they wanted you to determine the value of the unknown variable. A variable is supposed to represent some number that you don't know. Unless you're evaluating, you don't know it because, when you evaluate, they tell you what the variable is. When you're solving it, you have to let others know. Okay? So to solve an equation, all the steps to solve an equation are used to remove any terms or coefficients away from the variable. Only when the variable is isolated or all by itself is its value determined. So that's going to be your goal when you're solving equations, is to get your variable all by itself. You'll often hear an equation called a one-step equation, and that's what we're going to be looking at today. A one-step equation is an equation that only requires one operation, either addition, subtraction, multiplication, or division, to be undone from the variable in order to get that variable all by itself. Remember, expressions cannot be solved. All they can do is being simplified. But an equation has an expression on both sides. Each side can be simplified, but like terms on opposite sides of an equation cannot be combined unless you move them. You move the like terms so that they're on the same side together. You do this with what's called inverse operations. In today's lesson, we're going to be looking at the inverse operations of addition and subtraction. Addition and subtraction are inverse operations of each other. To undo addition, you have to subtract. To undo subtraction, you have to add. Now the steps to solving an equation are still on this note page, but I'm going to bring it over to our first example problem on the practice page. Okay, so I'm looking at the first problem on your practice page, and in the box on my screen I have the steps for solving addition and subtraction one-step equations that is also listed on your notes page. So we can solve this equation using 3 steps. The first step is identify your variable and constant terms. This will help you determine what you need to move. So I like to put squares around my constants and circles around my variable terms. Don't forget to include the signs when you're identifying your constants and your variable terms. You don't want to do this. Just a second, let me show you. You don't want to do things like this. Oops. Which seems like it's not any different than what I already did, but if you forget that that addition sign goes with that n, it could cause problems later. Alright, so let me do this again. I'm going to identify my constants. They are -5 and +8. They are constants because there's no variables. And then my variable term is the positive n. So the second step says move the constants away from the variable using its inverse operation. So this is important to know which variable you are going to move. Remember, you only move the constant that's on the same side as the variable. In this case, the -5 is the constant we need to move, not the 8. Your goal is to get that variable all by itself. We're not going to move our variables, we're going to move everything else away from it. So the inverse operation, if this is a -5, which also means the same thing as like a -5, the opposite of subtraction is addition. So what you will do is add 5 to both sides of the equation. The purpose of doing that is that in the next step, when you combine your like terms, if we write in that +5, we combine our -5 and our +5, that's a zero pair that we created. And that's how it becomes eliminated from the left-hand side of the equation, so that the only thing that's left is your variable, the n. On the right-hand side, when we combine the two constants together, we have a +8 and a +5. Those are same signs, so we have to add. It's 13. Whenever you're solving an equation and your variable is all by itself, then that's how you know you're done. Our answer is +13. You can always use evaluation to check your answer. There's no sense getting it wrong if you can just evaluate. So what I mean by evaluating, now that we know what our variable is supposed to equal to, you can rewrite the equation, but substitute your variable, in this case the n, with the value that you think it is, the 13. If you evaluate both sides of the equation, they should equal each other. So -5 and +13, if we combine those together, those are opposite signs, so we have to subtract. Well, 13 minus 5 is 8, isn't it? Which is the same thing as 8. So it checks. Therefore, we just proved that n is equal to 13. Let's try another one. Alright, if you look in problem 2, let's identify our variable and our constant terms. Well, r is our variable. That's what we're going to try to get all by itself. And our constants are -15 and -13. So which one of those constants do we need to move? The -15, because it's on the same side as the variable. So we're going to write its opposite operation. Instead of a -15, we need a +15. +15. I draw a big fat line and I'm ready to combine. So when I combine the -15 and the +15, they cancel out and equal 0. So the only thing on my right-hand side of the equation is just that r variable. Do copy down and bring down your equal sign. That's important. I see some people do a line kind of separates the left and right-hand side of the equation. That's fine, and that helps. For some people, I like to say if you cross the line, you change the sign. So that 15 that we had to move to the other, so that negative 15, if we need to move that to the other side, we write it as a positive 15. It's just another way to think of it. But just don't forget that equal sign when you write your answer, though. So we have a negative 13 and a positive 15 we need to now combine. Those are opposite signs, so you have to subtract. And because 15 is bigger and positive, your answer is going to be positive. 15 minus 13 is just 2. So our answer, 2 is equal to r, which is okay for an answer, but who really says that? When somebody says 2 is equal to r, that does mean the same thing as r is equal to 2. It's just a different way of saying it. If you want to, when you're all done, as long as your variable is all by itself, flip it around, you can. It's sort of like saying, Stacy is my name. Isn't it more common for people to say, my name is Stacy? It's the same thing. 2 is equal to r, or r is equal to 2. It means the same thing, but we're used to saying our variable first. So you may turn it around once you get your variable all by itself. Once again, let's check our answer to make sure we have it right. Rewrite the original equation, but wherever you see the variable, replace it with the value that you just discovered. So we think that r is equal to 2. So we replaced our r with 2 instead of writing r. Evaluate both sides of the equation. So on this side we have this negative 13. That can't simplify any further. And on this side we have 2 minus 15, which is positive 2 and a negative 15. Those are opposite signs, so you have to subtract. Equals 13, but the 15 is bigger and it's negative, so the bigger sign is 13 equals 13. Or negative 13 equals negative 13. So I know my answer is correct. Let's do maybe 2 more, and then I'll let you do the rest of the practices and check yourself at the end. Alright, in problem number 3, you have 4 is equal to n plus 18. Alright, so once again, let's identify our terms. You have a constant, a variable, and a constant. We need to get rid of those constants from the variable. So which one are you going to move? Hopefully you said the 18. So how do we move it? If it's a positive 18, you have to write negative 18. And you write that on both sides of the equation. Draw a great big line and combine. If you notice, I like to rhyme a little bit. So plus 18 and negative 18 creates a 0 pair. They cancel each other out. And n is then equal to 4 minus 18. Those are opposite signs, so you have to subtract negative 14. You may flip it around because the variable is now by itself. N is equal to negative 14 this way. Alright, go ahead and start on number 4, and when you're ready for just to check to see if you're doing the same steps, push play, or if you get stuck you can push play. Alright, let's see how you did. Did you identify 19 as a constant, and the positive a as a variable, and the 32 as a constant? So you see that the constant that's on the same side of the variable is that 19. Now let's see if you did this. Did you realize that because 19 didn't have a sign in front of it, that was a positive 19? So the only way you can get rid of it is with a negative 19. Whatever you do to one side, you have to do to the other. Draw your big fat line to combine. I'm going to emphasize drawing a line all the way across. Don't do this, and I'll tell you what, it's going to cause a problem later on when we get to other types of problems. Don't make 2 little short lines like this. It will get confused with division later on when we do use division. So when you're ready to combine your like terms, do draw a line all the way across the problem. Okay, so we have positive 19, negative 19. Did you cross them off to show that they're a 0 pair and the only thing you had left was the positive a? If you wrote the plus sign in front of it, it's not going to hurt anything, but you know that the plus sign A and just A all by itself does mean that it is by itself. Just to be less confusing, I'll take it off. And then we have 32 that you have to combine with a negative 19. Those are opposite signs, so you have to subtract. 32 minus 19 is 13. And 32 is bigger than the 19. It's positive, so it stays positive. So A is equal to 13. I am going to go ahead and check my answer. It is worth your time to check each one rather than missing it. A lot of people that don't want to check their work when they could have saved them their score on their test if they just would have plugged it back in to check their answer. Let's see, does that equal 32? 19 plus 13, well 9 plus 3 is 12, carry my 1. That's 32, yep. Especially if you're not using a calculator, please check your work. Okay, you have the rest of the problems to do for practice. If you're still stuck or need some more help, please see an instructor, but I think you can do this.